Dear colleagues, I would like to start this session. I would like to start the session with a warm welcome to all our guests, our colleagues, our partners to join us in this session. I would like to take you to a journey to the future of wastewater management in Jordan. Imagine a future where we look at artificial intelligence guiding our implementation at wastewater treatment plants, at data-driven implementation, and at collaboration between science and implementation. So welcome to the session of Bridging Science and Cooperation for Efficient Wastewater Management. We want to look into the collaboration between Aqaba Water, Columbia University in the US, and GIZ. And I want to give a special thank you before we start to engineer Yasser, because without him, this collaboration would have not been possible, actually. So thank you. Now, we would like to start with a presentation by my dear colleague Hind Al-Steifat. Hind is an experienced water and environmental engineer with over 19 years of expertise in integrated water resource management, wastewater treatment, and institutional development. And she is currently working at GIZ as a water and sanitation advisor and leading the activities on enhancing operational efficiency through technical sustainable management and capacity development in the wastewater sector. Welcome.
Good evening, everyone. I will be, thank you, Minter, and I will be introducing the, I would say, the part of this cooperation from GIZ perspective, how GIZ is looking into improving the wastewater management through using modeling and scientific-based approaches. An overview of the project is a strategic partnership between Aqaba Water Company, Columbia University, and GIZ. Aims to enhancing wastewater management and to foster the management of wastewater treatment plant operation and maintenance, as well as ensuring quality standard in the sector. Focus on science-based approaches and effective stakeholder engagement. So we are not only looking for the implementing or for the governmental stakeholder or implementing a stakeholder, but we are looking into the scientific and research institute in this regard. The primary objective of this cooperation was to elevate the integration of non-sewer sanitation, which we refer to as NSS, technology into existing centralized sewer system at the Aqaba Wastewater Treatment Plant. The specific objective for this cooperation was to introduce a pilot wastewater monitoring system, assess the impact of wastewater treatment processes, and improve the plant operation and performance as an overall target. The partnership overview. This partnership started immediately after the COVID-19, I would say. We start to look, as GIZ, we wanted to look into the improvement of wastewater, to look for wastewater as a source for information and to evaluate the potential in the Jordanian wastewater sector. And the idea came that we want to also use modeling, AI, computerized system to look into the this valuable, I would say, asset that contains a lot of information or static regarding the population, regarding the industry in Jordan, and different sectors. So during the World Water Week, we were introduced to our presenter, Professor Kartik from Columbia University, and we had the discussion regarding the potential of cooperation into this very specific sector. So this cooperation, I would say, started in another water conference, which is, I would say, always the benefit of attending such conferences is to build on the experience we learn and to bridge like cooperation among different regions and different countries. The cooperation started in a small discussion, which we took later on to Aqaba Wastewater Treatment Plant. Within the engineer Yasser Hanaqta was the director of the treatment plant, and he was so much in favor of advancing the management into a new aspect, into a scientific-based aspect, and to leave, I would say, not the conventional, but the normal ways of treating wastewater. So Aqaba Water Company in this partnership was a local authority responsible for the water and wastewater. Columbia University, as I said, responsible for the scientific approaches, and for GIZ implementation supported, and technical expertise were provided through this cooperation. Wastewater monitoring system. Within this, I would say this cooperation, we aimed at the introduction of advanced monitoring system at the Aqaba Wastewater Treatment Plant. The key objective of this monitoring system to evaluate wastewater quality, track treatment performance and operational tools, data. And the other, I would say, aspect was using the advanced modeling technologies, which we refer to as activated sludge models, ASM, and the BioWin modeling program. These are two programs that we are using into this cooperation, and we are trying to enhance the sector capacity in dealing with computerized system. The ASM, I would say, the overview of purpose modeling biological treatment process in this aspect. It helps predict system behavior and performance under different conditions. So the wastewater treatment plant manager would understand what is coming to him, how would he react spontaneously, and how we'd have, like, he prepare scenarios in advance to the quality of received wastewater. The BioWin modeling program, the purpose is detailed simulation of wastewater treatment processes, and it also allows for optimizing of plant operation and the configuration adjustment. So you don't wait until you have the problem, but you already have in advance a solution, or you are already prepared to receive such quality or to deal with such problems. The impact of the industrial wastewater, I would say, in Jordan we have, we all know that the wastewater sector has challenges dealing with the industrial wastewater. Either it is from industrial cities, or it is from the olive production. Different industrial wastewater are like they end up in the treatment plant, either via the sewer connection or via tankers. And these problems we have to deal with. It is a challenge that exists, but we have to deal with. So the expected outcome from this, I would say, using the digital modeling is to enhance understanding of the wastewater treatment dynamics within industrial inputs, and recommendation for improved system and integrations. Treatment configuration and optimization. The treatment configuration, I would say, it goes to the current treatment configuration, overview of existing treatment processes at the Aqaba plant, optimization goal, improving operational processes, especially in Aqaba wastewater treatment plant with the new industrial discharge to it, to achieve better treatment and effluent quality at the end of the day. As I said, there's a stakeholder engagement, and the purpose is to the importance of effective collaboration, enhancing local authorities, researcher and technical expertise, ensuring community involvement and knowledge sharing. The approach to stakeholder engagement was always consultation, ongoing meeting, and we have different kind of workshop online and on personal assessment. For Aqaba Water, I would say the expected benefit from this cooperation is improved efficiency of wastewater treatment, reduce environmental impact, especially Aqaba wastewater treatment plant is in a very critical area where it's connected to the shore of Aqaba. There is also the royal palaces next to it that we need to meet the standards of the effluent going out from the treatment plant. For Columbia University and GIZ, I would say this is a practical practical application of advanced research and models, contribution to global wastewater management knowledge. This approach is, I would say, very new to Jordan. We know that there is some consultancy companies working in such models, but we wanted to build the capacity of the governmental sector to understand, to develop, and to use this kind of modeling and scientific-based approaches in managing this vital sector. The key points and next step, I would say the outcomes is this, we managed to have this cooperation for 2 years between Aqaba Wastewater Company, GIZ, Columbia University, pilot wastewater monitoring system to evaluate the NNS integration into the system, use of the advanced modeling techniques to optimize the treatment plant. The next step will be that we continue the monitoring and refining system integration into Aqaba wastewater treatment plant until we finalize the model and could also upscale it or take it further to other treatment plants in Jordan, and share the finding for a global application in wastewater management, like reporting for the SDG, having I would say figure-based approaches in reporting for the climate change, for the SDG, different reports mechanisms. Thank you so much.
Thank you, Hind, for this overview. Before we move on to a more scientific point of view, I would like to first welcome Engineer Feras Al-Hamaise from Aqaba Water, and to give us some more insights into the Aqaba wastewater treatment plant and also into the implementation of what my colleague Hind just mentioned on the modeling and the process optimization and the goal of this collaboration. Engineer Feras is currently working as the acting head of Wastewater Plants Operations and Maintenance Department in Aqaba Water Company and has 10 years of experience in the wastewater sector. He is also a certified inspector for TSM and a member of the Water and Energy Sector Skills Council. So I would like to welcome Engineer Feras, please.
السلام عليكم، يعطيكم العافية جميعا. فراس الخماسي، مهندس تشغيل وصيانة محطات تنقي بشركة مياه العقبة. إن شاء الله بدنا نحكي عن المشروع التشارك اللي صار ما بيننا وما بين جامعة كولومبيا بوجود الGIZ. الفكرة من المشروع أو هدف المشروع هو تطوير وتحسين عملية معالجة المياه العادمة لمنطقة العقبة، لأنه محطة العقبة تخدم مدينة العقبة بالكامل. بدي أحكي عن موضوع ليش محطة العقبة أو ليش الهدف أو الهدف الأساسي من وجود محطة العقبة. العقبة انبنت محطة تنقية العقبة في 87، كانت عبارة عن محطة طبيعية. المحطة الطبيعية كان المخرج تاعها بنسميه كلاس سي، نوعية من المياه المعالجة نوعا ما تستخدم لغايات قليلة جدا، وهي زراعة أو سقاية النباتات ذات ساق طويل مثل النخيل. بال2005 تم بناء محطة معالجة ميكانيكية وتم بناء منظومة لإعادة الاستخدام المياه المعالجة. من هون صار في عندنا مصدر مائي جديد بخصوص مدينة العقبة، بحيث وفر عائد من ناحية كمية مياه ونوعية مياه نظيفة تستخدم لغايات الزراعة ولغايات الصناعة، بالإضافة إلى عائد مالي لشركة مياه العقبة. بال2016-2017 بلش عملية تطوير وتحديث وتوسعة للمحطة اللي موجودة حاليا، بحيث تبلغ نرفع الكباسيتي تاعها من 12,000 متر مكعب ل 28,000 متر مكعب، بصير اراوند ال 40,000 متر مكعب التوتال كباسيتي للمحطة اللي موجودة عندنا، بالإضافة إلى إضافة منظومة إعادة استخدام الحمى أو إنتاج البايوغاز والكهرباء من الحمى، وغير عن إنه في إعادة ريوز أو إعادة استخدام لمياه المعالجة المنتجة من المحطة. لذلك إحنا احتجنا نحافظ على نوعية المياه الداخلة إلى المحطة، بالإضافة لأن أنا أعرف أو أتعاون مع أجيب لي تولز أو أداة تحسن لي عملية المعالجة داخل المحطة، بحيث المحطة الجديدة هي محطة حساسة زي ما حكيت لكم، بتنتج كهرباء او بتنتج غاز حيوي. الغاز الحيوي بننتج منه كهرباء بوفر اراوند 60% او بغطي 60% من استهلاك المحطه ككل. بالاضافه انه انا عندي اعاده استخدام للمياه المستصلحه، حيث المياه المستصلحه اللي موجوده حاليا تغطي اراوند 30% من احتياج مدينه العقبه للمياه لغايات الزراعه والصناعه. لهون الهدف انه انا احافظ على المحطه وديمومه المحطه والشبكه. هذا الحكي بيوفر علي او بيساعدني في موضوع انه الحفاظ على المياه والحفاظ على الطاقه اللي انا بنتجها. بدايه المشروع بلشت انه طلب منا داتا بما تخص الشبكات، بما تخص المحطه، بما يخص الديزاين او البايو وين تمبلت اللي تمم عليه تصميم المحطه. بال 2022 حصلنا على تمويل من بلجس بالتشارك مع جامعة كولومبيا ووجود الجي اي زد. الهدف منه انه عمل موديلنج او تصميم لمحطة تنقية العقبة اللي موجودة عندنا لرفع كفاءة عملية المعالجة وتحسين منظومة الصرف الصحي في المدينة بالكامل. الداتا اللي تم جمعها او تم تزويدها من شركه مياه العقبه لجامعه كولومبيا وللجي اي زد. اول شيء تم تزويدهم بشبكه الصرف الصحي، المابس تاعت السيور نتورك كامله، جي اي اس، الاوبريشن داتا الخاصه بمحطه التنقيه، مثلا الفلوز اللي بدخل عليها، التمبريتشرز، البي او دي، الاس ار تيز، كل هاي تم تزويدها لجامعة كولومبيا بهدف تحضير الموديلنج اللي حكينا عنه اللي راح يساعدني في عملية تطوير وتحسين عملية المعالجة في المحطة. كمان تم تزويدهم في الموديلنج بروفايل، البايو وين بروفايل اللي هو خاص باللي تم عليه توسعة المحطة وتم عليه تصميم المحطة الجديدة. تم في عملية اجتماعات، صار في اجتماعات عديدة ما بيننا وما بين كولومبيا وما بين الجي اي زد بما يخص هذا المشروع وتطوير المشروع ووصول والوقوف عند كل النقاط اللي احنا استشاريين فيها. انطلب منا انه كمان بعد ما ان شاء الله الموديلنج يجهز خلال الفترة هاي راح يتم مقارنة الداتا ما بين اللي خارجة من الموديلنج وما بين الواقع اللي موجود عندنا في المحطة التنقية. بالإضافة إلى طلبوا منا عمليات تحسين أو تركيب سنسورز إضافية داخل محطة التنقية تهدف إلى رفع من كفاءة الموديلنج أو تحسين عملية الموديلنجز والنمذجة لتشغيل المحطة. سوري. كمان الهدف من التشارك ما بينه وبينهم انطلب او بالاحرى من ضمن الشغلات اللي مطلوب من شركه مياه العقبه انه هي تتابع هذا المشروع، تساعد في تركيب هذه الاكوبمنتس. راح يتم تركيب وتوريد كمان اكوبمنتس ومعدات وسنسورز لمراقبه الشبكه المياه المعالجه بالخارج. تم عمل خلينا نقول مسح ميداني للمواقع الصناعيه اللي موجوده في العقبه ومعرفه المواقع اللي يمكن ان تخرج مياه صناعيه تؤثر على نوعيه المعالجه في محطه التنقيه. هاي المواقع راح نحط عندها سنسورز، الهدف منها انه تعطيني الارم مسبق انه نوعيه المياه اللي راح توصل للمحطه راح تكون مخالفه وراح تتعامل باي موديلنج كذا كذا كذا، راح نسوي الترابل شوتنج كذا وكذا وكذا وكذا. الفكره الثانيه انه انا اقدر اضبط المنظومه هاي وانه احاسب او اني لانه اغلب المخالفات بتصير خارج اوقات العمل الرسمي، فانه لما يكون عندي مراقبه من السكادا روم متابعه على شبكه الصرف الصحي، هذا الحكي كله بنضم لي وبحافظ لي على منظومه الصرف الصحي اللي موجوده عندنا. الداتا اللي تقدمت زي ما حكينا تقدم لهم داتا للسيور نتورك وتقدم لهم للاوبريشن ريبورتس والموديلنج داتا. تم تحسين وتطوير في محطة التنقية بحيث انه مثلا خلينا نحكي عن احواض التهوية تم تركيب فيها سنسورز للدي اوز للاو ار بي للتمبريتشرز. هذا كله الحكي بيسهل عملية الانبوت داتا اللي راح تدخل على الموديلنج تاع البرنامج. تم عمل فحوصات لنوعية المياه اللي موجودة بالشبكة وتم رصد كم من موقع زي ما حكينا وتعمل مسح ميدان لكم من موقع فيه مخالفات لنوعية المياه اللي راح تدخل على المحطة. وسوينا سيناريوز إذا دخلت المياه مثلا دخلت نوعية مياه مخالفة بنوعية كذا، شو هي السيناريوز والطرق اللي راح نتعامل فيها من خلال الموديلنج. هاي جزء من الداتا اللي تقدمت لجامعة كولومبيا بما تخص الأوبريشن داتا تاعت المحطة، تشمل الفلوز، البي او ديز، الأحمال اللي بتدخل عليها، بتشمل السوليد ريتنشن تايمز تاع المحطة. هاي كلها إن شاء الله راح تصير هي اللي مثلا خلينا نقول راح تقول لك ارفع راز او قلل واز او التمبريشر. راح يصير انت كمان لقدام نقارن ما بين الموديلنج، بقول انه التمبريشر بحوض التهويه راح يكون 25. اذا لقينا في اختلاف راح نرجع للجماعه ونطور ونحدث في الموديلنج اللي موجود عندنا. الهدف الاساسي منه تسهيل عمليه مراقبه وتشغيل المحطه التنقيه. زي ما حكينا الهدف من المشروع بالكامل اني انا راح ارفع واحسن من عمليه المعالجه، بحيث اني انا راح يكون ريسبونس تايم تاعي اسرع اذا انا راح اعتمد على الموديلنج بموضوع اتخاذ القرارات التشغيليه المناسبه. الشغله الثانيه راح انا اتفادى اي ضرر راح يدخل على المحطه او نوعيه مياه مخالفه. زي ما حكيت لكم المحطه هاي حساسيتها انه المياه اللي خارجه منها يتم اعاده استخدامها بشكل كامل، ناهيك عن انه بيتم انتاج طاقة من السلج المخرج منها، فإنه توقيفتها أو الحاق الضرر فيها راح يضر المنشأة أو مدينة العقبة بالكامل. فإن أنا أكون مستبق الأحداث أعمل باي باس على منطقة معينة ورجع الفلو باتشنج. الشغله الثانيه انا احافظ على استدامه الشبكه والتطوير والابتكار بهدف زي ما حكينا مياه العقبه كانت ب 87 المحطه كانت محطه طبيعيه، بال 2005 صارت محطه ميكانيكيه مع سور مع ريكليمد ووتر نتورك، بال 2016 2017 2020 بتحكي انت عن محطه جديده بتكنولوجيا جديده بمعالجه للبايوغاز او معالجه للسلج من هدف منها انتاج الغاز والكهرباء. أنا بكون هيك خلصت، يعطيكم العافية جميعا وشكرا وآسف على الإطالة.
Thank you, Engineer Firas. Yes, you can take a seat already on the panel. Next, I would like to welcome our distinguished guest, flew in from US yesterday, Professor Dr. Kartik Chandran. He will give us some more insights into the real-time monitoring and performance optimization and the scientific approaches behind this part of the Columbia University research. Dr. Kartik is professor of the environmental engineering at Columbia University, and the main focus of his work is on understanding and re-engineering the microbial nitrogen cycle while exploring its links with the carbon, water, and energy cycles. Applications of his work include energy and resource-efficient technologies and approaches for biological wastewater treatment and sanitation in both developed and developing economies. Welcome, Dr. Kartik.
Okay, thank you very much for this kind invitation. It's a pleasure to be back in Jordan and see old friends and make new ones as well. So as Minche suggested, I'll give a brief overview of some of the aspects of this collaboration. As has been mentioned by both speakers, I was fortunate enough to be part of this collaboration as we were kind of shaping it even in 2022. Which is when I had the pleasure of meeting also people like Engineer Yasser, who's here in the audience. And so one of the main driving motivations for this approach specifically is that when we take a look at wastewater treatment, the overall sector today, there's been a substantial transformation, not just in terms of the technologies that are employed, but also the need for the technologies to have been modified quite a bit. So if we envision the top level kind of narrative there to perhaps describe what used to be wastewater treatment. Initially, all that wastewater treatment was, it was just essentially a ditch lined with let's say impermeable concrete through which we would circulate sewage, and then we would just let the sewage just recirculate for some time, and then we would achieve some degree of treatment, and that was enough at that point, essentially because of lower pressures associated with smaller populations, let's say, complete understanding relating to climate issues and other links between water sanitation and disease. But if we now take a look at what we are demanding of our wastewater treatment sector now, that picture has completely changed. So it's not just regular organic carbon, COD, and solids that come in, but now we are talking about, and which is especially relevant to this project, starting in Aqaba, is that there could be also the influence of industrial contributions into the wastewater, into the sewer shed as such. And so these industrial contributions could be organic chemicals, they could be heavy metals, mixtures, which essentially occur in a fairly non-systematic fashion. And so we have now to obviously consider the impact that these streams will have on what is happening inside this box, inside the treatment box. And to add to the complexity and add to the demands that we are now imposing on the plants, these plants now don't just have to meet regulations in terms of effluent organic carbon or suspended solids. We are demanding that these plants add on the layer of nutrient limits in terms of their discharges. We are talking about energy efficiency. We are talking about the greenhouse gas impact of the water sector as a whole. So the picture becomes quite a bit complicated. And so then the question is it enough for us just to monitor what comes in and what goes out at a fairly low frequency, just monitor solids, just monitor COD? The answer is obviously no. I'm glad to see people in the audience they're shaking their heads. So this is the picture that we are now currently dealing with. Then if we want to ask the questions of these wastewater treatment plants, we have to change the way we are essentially approaching this issue here. And so one way in which we could do this is to essentially go into the treatment box here, and instead of treating this overall treatment process as a black box. So a black box essentially used to describe what comes in, what comes out. We don't really care what happens inside, black box. So clearly that model is going to change. That cannot work in the treatment plant, in the treatment sector of tomorrow or even today, for instance. So then we have to start opening up that black box. So we can then the question is, how deep do we go? We can go as deep as we want, but there are practical considerations. What is the benefit if we open up each and every component, and we have to do this again and again and again? That is where modeling comes in. Modeling as a whole is geared towards unifying, let's say, the information that we get during any measurement campaign, unifying the knowledge into a systematic construct that we can use over and over again, and also synthesizing the data that we get, what is coming in, what is going out, what might be happening inside, but synthesizing that data into knowledge that the plant can utilize to, let's say, improve their operations. And operations doesn't mean just cleaner water in terms of just discharge into the environment. As we see here in Jordan, and increasingly so, where other countries can learn from a place like Jordan, is that how to, let's say, close the loop, and it's fine if it is for non-potable operations, non-potable reuse as well. And so that's really one of the utilities of going with a more data-driven, knowledge-driven, modeling-based approach. So let's come back to kind of what we are discussing here. As we envisioned this about 2.5 years ago, these were the initially envisioned proposed project outcomes, and this was with deep discussions with Aqaba Water and GIZ. And so here, as we see, there's a very nice umbrella under which we can frame this issue here. So zero discharge into the Aqaba, into the Gulf of Aqaba. And so to achieve such an overall goal, essentially what we need to do is we need to maintain stable operations in the face of unpredictable influent discharges, let's say from industries and so on, but also then potentially explore ways to improve the efficiency of operations in terms of the energy requirements, in terms of how the solids are being handled. There was a very nice discussion earlier this morning as part of the panel discussion in terms of more efficient biosolids management. Yes, there was a discussion around the production of biogas and the use of the methane in the biogas for combined heat and power, CHP. But I would also then challenge members of this audience to consider going beyond biogas, especially if we are talking about increasing the extent of nitrogen removal in the plants, increasing the extent of phosphorus removal, where if we don't just produce biogas, but if we produce the short chain carboxylic acids, which are a precursor to biogas, those chemicals can be fed back into the plant itself. So this does a couple of things. It essentially makes the process more stable in terms of nitrogen and phosphorus removal, while not needing to import organic carbon. Those carbon compounds are produced and utilized within the boundary of the treatment operations as well. So as you can see, these were the initial objectives or directions which were framed, but we can through additional discussions, we can choose whether to stick to these or if we want to perhaps address any other challenges which might be more relevant in today's environment. So again, now let's get into some of the details as time permits, and then perhaps there's more time during the question and answer session. So the overall proposed directions for Aqaba and other utilities as well, which might be interested, are as follows. So essentially, this is the information that Engineer Feras was also mentioning. So we are reliant to be able to do this. We need good quality data, because with models, I'm sorry to use a commonly used term, garbage in, garbage out. So we don't want that. We want good wastewater in, good wastewater out, good operations, no garbage. And so this is what we have. So we already have good influent and effluent data, performance knowledge. And so we essentially take what is coming in, what is going out, and how the plant is running. Those are the three components that we need at the very least. And then we translate that into a digital version of the model. And again, there was a discussion around digitizing this overall sector, and this goes directly into what was discussed. And then what happens is as follows. We essentially, through the approach of model calibration, we attempt to match what is being measured in a discrete fashion every day, multiple times a day. This is all fed into the model, but now the model is trying to essentially use equations and fit the equations basically to be able to describe what is happening in reality. And that is what we use the term calibration to describe. And so once the model is calibrated, we now have a digital version of the model. Now we can push and pull. We can run different scenarios. We can consider different problems that we might need to address. For instance, the non-systematic impact of industrial discharges into the influent, the sludge being trucked into the Aqaba plant that we observed last time, any efficiencies in terms of the wastewater quality, in terms of the biogas yield, and energy utilization for, let's say, nitrification and so on. So all of this now can be tested using the modeling approach. The other aspect that we can also do with some of these specific models is that we can also quantify the amount of specific greenhouse gases, specifically nitrous oxide, that is being emitted through nitrification and denitrification, which are processes built into the actual process, but also the model as well. So essentially, we have a tool now that we can use to test different scenarios. With modeling, what we also, with wastewater process modeling, what we also need to understand is that the calibration may have occurred based on historic data, which is what we have now. But we must also understand that these are real, live biological systems, and they're not static, they're not stable. So they keep changing as well. So from time to time, what we need to do is make sure that the model remains calibrated. And so that is where aspects of machine learning and AI-based and machine learning-based approaches come in as well, to make the overall process more efficient, to keep the model representative of what is happening. So it's this back and forth. We just don't calibrate once and walk away. We have to keep coming back and make sure that the model actually holds. And then one of the primary objectives also in this overall activity, as was also mentioned, is to build this capacity in-house within the water utilities here in Jordan, starting with Aqaba. And I just want to take the next few minutes very quickly to describe some similar work that I myself have been involved in. A current project that I'm involved in includes development, calibration, and utilization of similar models for one of the plants in the city of Beijing. This is near Washington, D.C. These are water reuse plants out in California, non-potable reuse, similar to what we encounter here. Here it is nearly 100% turning back into non-potable reuse. Again, driven by demands there. This is let's skip this. These are just the different steps. We could come back to this. And I want to then take you to two specific case examples. I'll start many years ago, starting actually in the previous century. I was involved in a project that where we were asked to redesign the wastewater infrastructure for the entire city of New York. In terms of scale, well, this is New York City overall. The population is about 8.4 million people. There are 14 wastewater treatment plants, as are described here. The collective volume of wastewater that we treat is 5 billion liters per day. 5 billion liters per day. So that's quite substantial. Beginning in 1999, our challenge was, and I used to work for a different institution then, Metcalfe and Eddy. For those of you in the wastewater field, perhaps recognize the name. So Metcalfe and Eddy was charged with redesigning the wastewater treatment systems in New York City to meet very stringent goals, to go from non-nitrogen removal to nitrogen removal, down to very low limits. And so this number here, 74,000 pounds of nitrogen per day, just for 4 of those plants there, corresponds to about 3 to 6 milligrams total nitrogen per liter, down to low water temperatures of about 11 to 13 degrees. So very challenging. The other challenge we were given was we did not have any room for any expansion, no new construction. So we essentially had to take the plant, and without doing anything, we had to see how much we could squeeze. And there was no other option but to use the models that were available then, 25 years ago, to essentially do this. And this is what we did. That's the configuration that we employed. And based on this, and the point is, these systems are now running. And this is the approach we are proposing for Aqaba with GIZ. It is exactly the approach that was followed, but using models that are perhaps a bit outdated. Now, things have progressed. And then more recently, now going to the other end of the spectrum almost, this is another plant I designed in Kumasi in Ghana, where there are some details here as well. But the point here was we were not even treating sewage. We were treating a stream that is described, that the term that is used to describe it is fecal sludge. Fecal sludge is, it's a little bit more than concentrated wastewater. There's also a high degree of variability and extreme variability. But again, our approach was to design and run a treatment plant for 20,000 people. And essentially what we did is, again, very similar to what we are proposing here. Took historic data, combined with more contemporary measurements, and then design and run a treatment plant. So this was going from the complete absence of any treatment to treatment. So it was a 0-1 kind of a jump that was again enabled through essentially the same approach. I'll skip this slide as well. So essentially, in summary, modeling just allows us to basically make sense of some of the variability that manual analysis we may miss, and essentially to make the analysis, design, and optimization give it a bit more automation. And that's essentially what we are proposing here. Uniquely as part of this project, we also propose to incorporate, let's say, early warning signals that reflect what is coming into these plants. And that's not modeling, that is actually better sensing, better analysis. And all of those sensor inputs are expected to feed into the model as well. And there is also an angle of an aspect of hydraulic characterization, as we discussed last time, that could also help with the overall digitization of this process. Thank you very much. I'm sorry if I went over time.
Thank you, Kartik. Even though I've listened to you a couple of times, it still always amazes me how much potential there is in wastewater data. Okay, we would like to move now to the second part of our session, panel discussion. I will start with a few questions myself, but please get ready if you have any questions. Raise your hands soon so we can see how much time we have. Kartik, I would like to start with you actually. Based on what you just said in your presentation, from a research and modeling perspective, how did you adapt your methodologies to the local context here in Jordan and to the constraints of Jordanian wastewater treatment plants?
Yeah, thank you. Yeah, this is very, very relevant. And so, as Engineer Feras mentioned, so the first step in really making our approach specific to Aqaba and specific to Jordan essentially boils down to the use of specific treatment plant data, influent and effluent, and process operating conditions. So that's the direct pathway to specificity. But I should also mention that this the system that we are talking about in Aqaba, and perhaps with the potential to expand to other systems in Jordan, I see very close similarities with some of the work that I've conducted actually in for treatment systems in North America, where again the focus is on substantial treatment of the wastewater, and now more and more so with the increased demand in terms of water reuse, wastewater reuse. So again, there is something to be learned there, but then bringing it back to the context of Aqaba, bringing it back to the context of Jordan, specifically that revolves using the data that we have here, the conditions that we have here, the operating characteristics of the plant here.
Okay, thank you. So Engineer Feras, looking at the Aqaba wastewater treatment plant and this pilot, what operational improvements have you observed already or might expect to see in the future as a result of this real-time monitoring and advanced modeling?
Speaking in Arabic, okay? طيب أنا زي ما حكينا المحطة هي كانت بال87 كانت محطة معالجة طبيعية، بال2005 صارت محطة معالجة ميكانيكية تخرج مياه نوعية منيحة. هذا بعطي انطباع انه الشركة في بالها في تطور في انجاز. بال2016 رحنا لاحدث تكنولوجيا موجودة بعد ما خف الطلب على نوعية المياه الكلاس سي وزاد الطلب على نوعية المياه الكلاس اي، وضغطنا باتجاه استخدام المياه المعالجة بغايات الصناعة، بحيث انه الصناعة ما في تذبذب بإعادة الاستخدام، بحيث انه باخذ من عندك على مدار السنه كامل نوعيه او كميه مياه محدده، الا بايام الشت داون بتكون 20 يوم 30 يوم بالسنه. بعد هيك طورنا المحطه اللي كانت قائمه بال 2016 2017. اشتغلنا تكنولوجيا جديده هي كونفنشن سيستم، محطه بنظام التهويه التقليدي بنتج منها نوعين من الحماء، البرايمري والسكندري، اللي تمت لهم عمليه معالجه الهدف منها انتاج البايوغاز. البايوغاز بدخل على كومبايند هيت باور جنريتور اللي هو مولد بيشتغل على البايوغاز بينتج لي طاقه. ورحنا بعدين باتجاه موضوع الموديلنج وانه يتم تشغيل المحطه بواسطه الموديلنج او اتخاذ الاكشنز عن طريق الموديلنج بعد ما ينعمل له كاليبريشن بالشكل الصحيح، وبعد ما الداتا تكون كلها كامله والمجموعه، ومع مراقبه الشبكات بحيث انه انا لا سمح الله اي تغير في نوعيه المياه يكون الرسبونس تاعي اسرع من قبل ما المياه توصل لعندي. لقدام بنفكر في موضوع اعاده استخدام الحمأة، في فكره لاعاده استخدام الحمأة اذا الموضوع راح يسمح لقدام، لانه تاخذ عينات من الحمأة الموجوده. الحمأة اللي موجوده حاليا الدايجستد سلج اللي طالع من الانايروبيك دايجستر في كالوريز فاليو اراوند النص اللي موجوده بالفحم، يعني بنقدر نستخدمه كمصدر للطاقه. ناهيك عن انه راح لقدام كمان اذا تم دمج الموديلنج اللي راح يصير مع السكادا سيستم، بحيث انه يصير الريسبونس من الاوتوماتيك من خلال منظومه السكادا اللي موجوده عندنا. شكرا.
Great, thank you for this answer. So the next question goes to Engineer Hind. How does this partnership that is supported by GIZ align with GIZ's broader strategy in promoting sustainable water and wastewater management in Jordan?
Thank you so much. I would say that as a German government, GIZ is responsible for capacity building in the partner countries like Jordan. And within this modeling, within this partnership with Columbia University and Aqaba Wastewater Company, we are looking to build the capacity of the wastewater sector to enhance their knowledge and to improve the operation and maintenance of wastewater sector in Jordan. That would give the implementation of various projects in the wastewater sector for the improvement, building, even establishment of new wastewater treatment plant. This will allow for sustainable management. It will allow for better operation and maintenance, and it goes along with with the GIZ, I would say, vision of enhancing the in-house capacity within our partner organization, like Ministry of Water and Irrigation and the water utilities in Jordan. It also goes for the sustainable approaches, to have more sustainable projects, to have more sustainable impact on the long run on the wastewater sector by, as I said, by building the capacity of the staff working in the wastewater sector, and allowing I would say, the Water Authority of Jordan also to have kind of monitoring, to evaluate their project, to read their tender documentation, to allow them for a better understanding of the future of the wastewater sector in Jordan.
Great, thank you. Before I ask more questions, I would like to open, the floor for the audience. Do we have a microphone? Yes, please, here. First question.
Okay, thank you very much. Dr. Mahmoud Shatat is academic and research and also WASH advisor. I have two parts of question. One related to research, and the second one related to operations. The first one related to research, as I understood from the professor, that the model now has been calibrated and validated, or in the process of validation to be used. Is there any methodologies of integrating AI afterwards, in order to avoid manual, operational scheme later on, as AI now is booming around the world? My second question related to operation. What the current situation of current utilization of treated wastewater in wastewater reuse, like agriculture irrigation or whatever in industrial reuse? Maybe my third question, as you mentioned that this treatment plant is currently covering, integrating the biogas system. How much energy produced by biogas system covered the total from the total operation system? Thank you very much.
Yeah, I can start answering the first question. So we do have a calibrated version of the model based on data which is pre-2024, I think. And so we will have to go back in and let's say update. As I mentioned, we just don't calibrate once, and then so we'll have to probably go back in and update it for more recent data, and then based on that we expect to run different scenarios. Now the question relating to the use of automated, let's say, approaches. So in some of the work that I mentioned that we've been doing in cities as part of other projects, we have already added automation, specifically for calibration, but also so the most of the simulations actually occur during calibration and optimization, and so that we have already automated. It's not AI based. It's just automating the whole process, but. There is another part of this overall work where AI actually comes in, and so that is identifying, for instance, so in this project, I see the use of large data-driven models, large language models, including AI, let's say to figure out the impact of these non-systematic discharges. So specifically, if we observe a deviation, an excursion from, let's say, routine performance, then the point is to then understand whether that excursion in performance is because of other influent discharges coming into the plant, or whether this is just inherent due to inherent plant dynamics and variability. That is where the use of data-driven approaches will come in. That's one. And as we are trying to optimize the plant, again, even with steady state influent characteristics, that's where ML will come in as well. We are actually using specific ML models to on a different activity where we are taking data from, let's say, all around North American plants, going back 10, 15 years, by the way, for which we have data. We are optimizing, we have optimized operations to minimize both the liquid phase discharges and the greenhouse gas emissions. So that's something that we could expand to the system as well.
السلام عليكم. بس بدي اضيف شغله على حكته المهندس هند، هو بخصوص انه راح يتم تدريب كمان الموظفين على استخدام الموديلنج اللي هم موظفين مياه العقبه، وعلى طريقه خلينا نقول عمل الحسابات اللازمه في الموديلنج والكاليبريشنز للموديلنج. بما يخص انتاج الغاز الميثان، هو بيعتمد على كميه السوليدز ريموفال اللي عندك في السيستم اللي في المحطه. مثلا كل 1 كيلوغرام من المواد الصلبه في 80% منه هذا فولوتايل سوليد. الفولوتايل سوليد هاي فيها 40% بايوديجريدبل ماترز. هاي ال 40% هي اللي بتتحول لبايو غاز. البايو غاز كل 1 متر مكعب تقريبا من البايو غاز بنتج لك اراوند 2.3 كيلو وات اذا كان عندك الكومبايند هيت باور سيستم 40%. نسبة الكفاءة تاعت السي اتش بي الموجودة عندنا هي 40%، فكل 1 متر مكعب من الغاز بنتج لنا اراوند 2.3 كيلو وات. المحطة حاليا بتنتج بحدود 3000 ل 4000 متر مكعب من الغاز الحيوي. هذا الحكي بنتج لنا بحدود 10,000 كيلو وات في اليوم. هدول سعرهم بحدود 1000 دينار يومي. هم بغطوا مع بي في سيستم، في نظام عندنا بي في سيستم كمان خلايا شمسيه، بحيث انه المجموع التو يونتس هذول مع بعض يغطوا لك اراوند ال 60%، لانه في عندنا بامبنج ستيشنز حكينا عنها خارج محطه المعالجه، او جزء ثاني من عمليه المعالجه، اني انا بضخ ريكليم دوتر، الهدف منها اعاده الاستخدام لها بمدينه العقب بالكامل، لانه إن شبكه بتغطي مدينه العقب بالكامل بحيث نوصل لكل الكاستمرز. عندنا كاستمرز كبيره، يعني من ضمنهم مجمع الصناعي بيسحب اراوند 7000 متر مكعب باليوم من المياه المستصلحه. الايله بتسحب 7000 كمان متر مكعب من المياه المستصلحه. الجزر الوسطيه في العقبه كلها مزقيه من المياه المستصلحه اللي خارجه من العقبه. الجامعه الاردنيه، المدارس، اغلب الشركات او اغلب المواقع السياحيه موجوده في العقبه بتستخدم هاي الريكليم دوتر لموضوع اعاده الاستخدام للزراعه والصناعه. زي ما حكينا المجمع الصناعي بيستخدمه في ابراج التبريد اللي عنده. هذا الحكي كله غطى 30% من احتياج العقبه للمياه. العقبه تقريبا تحتاج 90,000 متر مكعب في اليوم، 60,000 بياخذوها من مياه الشرب لغايات الشرب، و30,000 أو 25,000 سوري بيستخدموها أو بياخذوها من محطة التنقية أو التريدد ووتر بيدفع استخدامها بالزراعة والصناعة. شكرا.
Thank you for these impressive numbers. Can we have the microphone, please? Here.
Yes.
Okay.
I have already.
Okay.
Hello everyone, Michael Martin, Veolia, Technical and Performance Director for the region near Middle East. One question for Engineer Ferras and also another one for Professor Kartik. Engineer Ferras, you mentioned that you were monitoring the pollution in the full sewer network using sensors, so I was curious to know which kind of sensors plus conductivity, you will tell me. And in operations, are you facing some difficulties? Because we used to have some sensors in the network, but it's giving some difficulties in terms of operations to be sure that they are reliable and you can use the data. And for Professor Kartik, my question is, by the past in Suez and now in Veolia, we have, I would say, we are using BioWin and ASM1, ASM2 models and so on, but we saw also that we needed to modify those models in order to have them more accurate. So I wanted to know also if you change the library in the models themselves to adapt them to Akaba plant or not, and so on. Thank you very much for your replies.
بخصوص الأجهزة أو الفحوصات أو الأجهزة راح يتم تركيبها في النتوركس للشبكات الصناعية أو للشبكة أو بالمواقع اللي احنا فيها استخدام صناعي. راح نعتمد على 2 بارامترز اللي هم البي اتش والسي او دي لنوعية المياه بالسور نتورك. السي او دي الأحسن جهاز وصلنا له أو اللي احنا خلينا نقول جبنا عليه عروض سعر، هو بيحتاج لمدة 3 دقائق عشان يعطيك قراءة لنوعية المياه اللي بشبكة الصرف الصحي.
Yeah, thanks for the question on the model equations themselves. So far, the skeleton equations have not been modified at all right now. But as I said, we are going to go back and update the calibration even with more recent data. And at that point, if the equations do need to be modified, so in BioWin there is of course the gray box that is present, and we can modify equations if and as needed. In terms of the liquid phase equations, I think most of them are okay, except the one for nitrous oxide, where there's a linear relation between nitrite and nitrous oxide. So I think we'll do a little bit with that. On the biosolid side, with BioWin specifically, the limitation is that up till acetogenesis, everything just goes in one step. We might have to see, but then if we do that, then we need measurements on that side as well. So those are possibilities. We'll have to see what is needed. And again, I didn't mean to suggest that we are only going to use EnviroSim for this effort. It's just something that is very intuitive, and so that's where we started. And so we are also open to taking the equations completely out of the 3 or 4 programs that exist. So Sumo, Hydromantis, and one more. We can take those equations out completely and put them in another platform as well. Thank you. Very, very perceptive question.
Okay, hi. My name is Ayham Abidat, Senior Process Engineer from CVM Smith. Thank you very much for your presentation, the nice presentation that you prepared just now. My question is Dr. Kartik. I'm not sure if the BioWin model calibration is completed right now. If so, I would like, I have some questions about the calibration of the model. The aeration system, the result of the aeration system in terms of the number of diffusers that they are currently installed, if the airflow per diffuser will exceed the maximum airflow. This is the first question. The second question, from my previous experience with Akaba water in the treatment plant itself, the design of the treatment plant was designed based on SRT of 5.5 days. Currently, the plant is operated with almost 12 to 13 days. I would like, if the calibration of the model is completed, to see the results, the implication of operation of the plant of 13 days SRT from the increasing of the aeration system, the aeration requirements, in addition to the effect of increasing the SRT, because you know that the volatile suspended solids will be the reductions of the volatile destruction in the aeration plant, the aeration tank will be increased. So I would like to see the results of the impact of reduction of the biogas from the anaerobic digester. Thank you so much.
Yeah, thank you, Engineer Aham. Thank you for the model that you shared with us. So, and that's what I'm referring to when I say the calibrated version of the model. So we've not updated it. It's updated it at all. In fact, it is very interesting for me to learn right now at this moment that the operating SRT is quite a bit higher than the target SRT. So I think this merits a discussion again, perhaps later on. Also to see the trajectory, the time series profile of the SRT, if at all that is available, perhaps based on wasting rates and or something else that we need to calculate. Yeah, so this, I mean, the short answer to your question is the calibration has not been modified since the time that we obtained it from you, and I suspect now, hearing from you, that it does need to be. And we are happy to, of course, I mean, if it is acceptable to all the partners here, yeah, it's of course happy to have a discussion with you. Yeah, thank you.
You want to add something? No. Okay, thank you. Is there any other question in the audience? Yes, please. If we have the microphone, yes.
I am engineer Waddah Sadaqa from Yemen, Aden government, manager for wastewater treatment. Arabic, a question the Arabic. أنا أتفق مع الدكتور المهندس كارتيك حول ليس الداخل الرقب الداخل أو الخارج الرقبة، إنما كمان العمليات اللي تحدث في الوسط، هذه من أهم العمليات اللي تحدث. لكن السؤال المطروح في الحمأة الصلبة، الجزء الوسط أو في مدينة العقبة، التخلص النهائي في الحمأة الصلبة هل تستخدم للأشياء المقيدة أم الأشياء الغير مقيدة؟ إن كانت لا تستخدم فالتصريف النهائي يكون للمعايير. هذا بالنسبة إن كانت المحطة activated sludge، لكن إذا كانت المحطة طبيعية يكون مشكلتين في التخلص منها وفي التخلص منها من داخل الأحواض أو التخلص منها من نهاية التجفيف في المرحلة النهائية التجفيف. سؤالي المطروح هنا، التخلص من الحمأة الصلبة في الجزء الوسط إن كانت في المعادن الطبيعية أو في activated sludge الحمأة النشطة، هذا هو السؤال.
شكرا. زي ما حكيت احنا المحطة عندنا الحمأة نوعين، في برايمري سلج وفي سكندري سلج، حمأة أولية وحمأة ثانوية. هاي الحمأة بناخذها بنوديها على دايجستر أو انايروبيك دايجستر. الانايروبيك دايجستر باخذ ال 40% اللي هم أصلا من 80% البايوديجريدبل ماترز اللي الموجودة جوات المواد الصلبة هاي. الباقي بيطلع لنا على شكل حمأة، بروح على بلت بريس ماشين، ماكينة بتنزع المياه من الحمأة اللي موجودة عندنا، تطلع بالاخير على حوض تجفيف لاني ارفع نسبه خلينا نقول المواد الصلبه فيها فوق ال 50%. بعد هذا الحكي بتروح على المطمر الصحي او على مكب النفايات الصلبه.
Thank you. I would like to ask the next question to Engineer Ferraz. How is Aqaba Water planning to institutionalize this knowledge and the tools that you're gaining through this collaboration with Columbia University to ensure long-term sustainability and resilience in the face of shocks like the industrial discharge events?
اوكي، بدي احكي عن شركه مياه العقبه. فيها خلينا نقول الاشخاص الموجودين فيها مدربين ومهيئين ل خلينا نقول يكملوا مسيره اي نقطه وصلها خلينا نقول السيد كارتت او وقف عندها المشروع، وراح يتم تدريب زي ما حكيت. في ان شاء الله فكره ليتدرب موظفين او الاوبريشن تيمز الموجودين في شركه مياه العقبه على برنامج الموديلنج، بحيث انه قادرين على مواكبه او تشغيل البرنامج، ويظل او يظل الفكره البروجكت شغاله ما تتوقف. هي هاي الكونسبت تاع وهاي الفكره راح ينشغل عليها ان شاء الله. مياه العقبة تعتمد اسلوب انه دائما تكمل مسيرة. مثلا عندنا احنا اليوم عطاء تشغيل وصيانة للمحطة اللي موجودة حاليا، بناها مقاول مع تشغيل لمدة 5 سنوات. كان في فكرة انه المقاول ما يشغل لحاله المحطة، راح ينتدب اشخاص من موظفين مياه العقبة يداوموا معه فول تايم فور ريسبونسابيلتي، بحيث انه يتدربوا على تشغيل المحطة، قادرين بعد 5 سنوات او انتهاء فتره التدريب يرجعوا على المحطه ويقدروا يدربوها. وهذا راح يصير ان شاء الله في المشروع هذا. احنا راح نظل مع الجماعه لنهايه المشوار ونتدرب على طريقه استمرار وتكيف، نتكيف مع البرنامج وكيف حكيت له قدام اذا بدنا نربطه مع السكادا سيستم.
Thank you. Then I would like to pose a similar question to Kartik on what role does academic research play in building capacity, and how is Columbia University planning to transfer this knowledge to the utility and in the project?
Yeah, thank you. So to bring the activities full circle, so what role does academic research play in this overall, let's say, rejuvenation of the sector? And I think Engineer Hind mentioned this as well. For both, I think GIZ and Columbia, I think one of the highlights of this overall program is that we are taking, let's say, research that develops ideas that come out of, let's say, a more fundamental side of things, to take these ideas, take these concepts out into the field and apply them for the benefit of the sector. This to me reflects the highest degree of translation and knowledge development and knowledge exchange as well. Columbia specifically, and specifically as applied to this project, I'd like to draw on a couple of examples that are already going on. So as part of other programs, I have actually been interacting with the water utility sector, termed slightly differently in the country of South Africa. Since 2019, funded through the national government there and also the Water Research Commission, we competitively invite early career young engineers from utilities around South Africa to compete and take part in a competitive program. As part of this program, the ultimate objective is for these early career engineers is to, as part of just that program, is to redesign the system that they are actually running, their host water utilities. But then also the reason to tap into the early career engineers is that these are the engineers who are presumably going to be running the show a few years down the line. And so that is something, if we can do something like that, starting with Aqaba Water here, that could be quite nice. But as part of the same program, I physically go there and let's say share any insights that I can. But then we also invite the engineers over to come to the US, go to other countries as well, and directly interface with the water utilities in these other countries as well. So it's peer-to-peer learning as well. That is part of the program. So I mean that if it fits, if it is feasible, that could be a good, that could be a nice aspect of this program. Very similar, almost identical approach that we are using in the country of Brazil as well, which I think that these thoughts were just spurred on the moment by your question, Mincha. Thank you.
Is there any other question in the audience before I pose my last question? Okay. So then my last question goes to Engineer Hind. Are there any challenges that you have encountered in facilitating such a cross-institutional collaboration between academia and the utilities? How have you addressed them, if there are any challenges?
Thank you so much. I would say this is a very interesting question because we have a gap between science and implementation. I would say that most of the time you find a very interesting research or you hear very interesting presentation, but when it comes to real implementation on the ground, you face a lot of challenges because sometimes they are based on laboratory, sometimes they are only in-house research, but not implemented on the ground. I would say during this project, we faced some challenges from cooperation, data, like the allocation of data, what data the model needs, what data is available, the digitization of the treatment plant, the scales, this different small requirement made it sometimes difficult to bridge the gap between the model and what exists on real life. But I would say with great effort, I would say with dedicated teams, with people who are really engaging, who wants to do something and who wants to have this capacity, you can easily overcome these gaps and overcome these challenges. We had a very dedicated team from Aqaba Wastewater Treatment Plant, Aqaba Management as well, I would say from Columbia University. We know the Professor Kartik workload, even though he was always available for meetings. I would say also the distance between USA and Jordan made most of the meetings online. We had online meetings, checking the data, all of these. They were, I would say, challenges, but with the very dedicated team we had to, we could come over all of these. I would add also something that it's not only for the cooperation itself, it is the challenge also that you have intersectoral activities within different approaches in managing the wastewater treatment plant. GIZ did not also only focus in the modeling side. Modeling came as a consequence or as an I would say a closing scenario of building the capacity in the wastewater sector. We started from understanding the drawing of the treatment plant. I would say Engineer Firas is one of our modular training participants, because we started with how the sector could understand the basics of the treatment plant, then how they understand the calculation, then how they understand or modify, even evaluate the tender procedures of a wastewater treatment plant. Afterward, we thought about one comprehensive closing of all these training that came with the modeling approaches that will enhance the understanding of future scenarios. So there was challenging also in bridging all these activities together and with the moving sector in Jordan, but I would say that dedicated team, dedicated dwelling management would always make things easier to achieve. Thank you.
Great, thank you for this answer. Before we want to close the session, I want to give each of you just one last statement. You can choose if you want to talk about your main point of the session today, of the outlook, looking into the future, or any new enthusiasm that you gained from today's session. So you can choose whatever message you want to give as a last message. We'll start with Hind.
Yeah, honestly, I want to share that I was always motivated for this project. I always believe that we can grow faster if we base our implementation on scientific approaches. That science is there to make I won't say our dreams, but our ambitions comes true. And this is what I see, that we could grow in the wastewater sector in Jordan by having such innovation, such collaboration between scientific research institute and implementation on the ground. So I would say that I'm looking forward for the final output of this cooperation between the three of us. Thank you.
بسم الله الرحمن الرحيم. أول شيء أنا بدي أشكر المهندس ياسر الحناقطة، هو كان صاحب الأفكار هاي كلها من لما حكينا عن محطة التنقية الطبيعية لغاية ما وصلنا لمحطة بتعالج مياه كلاس A، بتعطينا مياه كلاس A وبتعطينا بايوغاز، ووصل فينا لمرحلة الموديلنج للمحطة. شكرا باشمهندس. من ناحية ما حكينا أنه نقدر نطبق، راح نقدر نطبق على أرض الواقع. دائما بداية خلينا نقول الخطوة الأولى بتكون صعبة. اللي بيفهموا في شغلنا بقول لك أنت صعب إنه أنت توافق ما بين الموديلنج وما بين الأوبريشن ب100%. بدنا نخوض التجربة وبدنا نحاول، وإن شاء الله راح نوصل لنتيجة حلوة، وشغل راح يطلع إن شاء الله منيح يرضي أو خلينا نقول يخدم مدينة العقبة بالكامل إن شاء الله. يعطيكم العافية جميعا. شكرا.
Yeah, I would also like to echo what was mentioned by the two speakers. In fact, I would like to actually, I consider myself very fortunate to be sitting here and even talking about my role in this project. I would just like to say that what I'm doing is I'm only connecting the dots. The dots are the questions which are being posed by Aqaba Water, by GIZ. And I'm happy that I'm able to do that with some of the tools that we have. Big acknowledgement to Engineer Yasser, who really was instrumental in framing these questions. And that, in that sense, I think the water sector in even some of the most developed countries don't ask such questions. So I cannot tell you how happy I am to be part of this overall program. Thank you to everyone.
Thank you. Thank you to the three speakers for joining the session today and for giving some insights into this great collaboration. Ambitious for the future. And yeah, as I said in the introduction, I think the future in wastewater lies really in data-driven implementation. And with this pilot, we are on the way to showcase what Jordan can do. And I think also part of the applause that will come will go to Engineer Yasser.